Hello and welcome. In this session, we are going to learn something about the concepts like the migration strategy for Postgre on AWS. We are assuming that a decision has been taken to migrate our either the PostgreSQL or any other relational database to uh, to be converted as Postgre on AWS. So AWS has been accepted as the cloud service provider, and the source may be either PostgreSQL itself or some other database. So in general, this is all about the migration strategy for relational database on AWS. So it's just a overview. When we are trying to modernize our infrastructure, the database comes at the core of it. And when we are talking about migration to the cloud, one of the things which comes into the mind is, shall we go to the same database, or is there a way in the long term, if we wanted to see it as an opportunity to re-platform our database so that we can use the features of the cloud, and going forward, if you wanted to reduce the licensing cost, and if our application, so the main thing is the application, if our application supports migration from the enterprise database, let us say from Oracle, we wanted to go to PostgreSQL. In that case, is that our application going to support it? So this is just a conceptual step only, wherein we have to. So this is something which directly comes from the application also. Like they wanted to re-platform the way they wanted to look into it. So assuming I have a PostgreSQL which is running on premises, and I wanted to take away all the management tasks. Say for example, I don't want to spend time on the management of the database, backup, the recovery part, the application, other things. So I would like to go into AWS cloud, and I wanted to provision my database, or I want to migrate my database as AWS RDS on PostgreSQL. We are not going to discuss about this particular scenario wherein during the re-architecturing way, the database has been transferred from enterprise to NoSQL database. So that's not part of the discussion. So what we are saying is there are two ways. One is we wanted to lift and shift. We simply take a backup of on-premises PostgreSQL and then put it into the cloud. And if you wanted to modernize it, the idea behind that is we wanted to use a modern engine which is going to be sustainable, which is going to be open source in the long run. So if you are talking about the phases of migration, these are the different phases. There are mainly four phases. This can be divided into several other phases depending upon like how you are thinking your migration will be. But there are normally four phases. One is, so we say it as PPMO, which is prepare, plan, migrate, operate, and optimize. The first phase is very critical phase, wherein we say we are going to prepare for the migration, wherein if it is not properly already analyzed, we will say what is the dependency between your application and the database. Have we properly analyzed, is it that both the application and the database is going to the cloud? Have we identified the workload? Are we assuming it is going to be rehosting? That means I'm already in the PostgreSQL on my on-premises environment. Assuming, let's say I'm on Postgre 10 and I wanted to go to the cloud, and I want it to be the latest version of the Postgre, which is Postgre 13, or I wanted to re-architect my migration. Say for example, I'm already on Oracle. Let's say I'm on Oracle 12c. I'm paying a huge license, and Oracle is the leader. There is no doubt in that. and the way this is charged, the license cost is charged is on CPU. So if you have a a database which is consuming a lot of CPUs, then you have to pay the licenses according to that. So but if you, in case your application accepts it and you wanted to migrate from your Oracle to PostgreSQL, this may be one of the opportunity wherein you are migrating to the cloud. You have an opportunity to migrate to the heterogeneous environment. That means you are in Oracle, now you wanted to go to the Postgre. So this is an opportunity which can be taken up. So you have two things. One is rehosting. You go to cloud, you be there in Postgre itself. You go to cloud, but instead of being on Oracle is just an example. It can be anything. It can be MS SQL, it can be MySQL. Say for example, you can go to finally the landing as PostgreSQL. If you're not analyzing everything in detail since the beginning, wherein you are talking a lot about the application, how is the application going to behave when you move your database alone to the cloud, or is it something, or your application is also going with in the cloud simultaneously. So those are the basic thing. And some of the important thing is either you are going for the homogeneous migration, you are going to stay in the cloud as the same, maybe Postgre itself, or let's say your source was Oracle and you wanted to re-architect, as you wanted to make sure that you go to the cloud as Postgre. If you're not deciding on what you are supposed to do, and later on you make your mind, okay, let's try changing our code from Oracle to PostgreSQL, then your migration strategy may be entirely delayed. So when you are identifying the dependency, say for example Postgre to Postgre in cloud, you need to check out how is your database being accessed by the other application. Is it just one application, or there are many applications which are going to access your database? Some part of it goes to application owner itself. They have to decide that that's the only application which is accessing your PostgreSQL. But let's say make some questionnaire for yourself also, wherein you will have these things handy. Is it your application accessing your database directly? Are you going to use the database link to fetch the data from some other databases as well? Let's say you moved one database to the cloud and there is other database which is there in on premises. So have you done the proper POC wherein the data is coming from several databases using the DB link? Do we have any application dependency on premises software? You need to check out that. Are there any kind of hardware dependency as well when you are talking to the Postgre, let's say, for example? Do you have any constraint in terms of the bandwidth of the network? Let's say I wanted my application, if my application bandwidth to the database is below this threshold, the performance will be impacted. So some of the things, is there any special database engine options or features which are using in on-premises? Do they need to be the same? Why we are asking those? Because we have two options. Either we go to cloud for Postgre on EC2, which is a rehosting, or you want it to be on RDS, which is relational databases for PostgreSQL. You need to check out the workload on your databases. Let's say you wanted to migrate from Oracle to PostgreSQL. Is your database heavily loaded? In that case, the amount of the what do you say, the efforts which is required to migrate, it is going to be huge when we are talking about the heterogeneous migration. In homogeneous migration, if there is no downtime, the proper downtime is not allowed. Nowadays, the challenge is most of the databases or most of the applications which are facing the internet, maybe they may be accessed 24 by 7. In that case, you have to make a strategy so that you go for the minimum downtime. So those things you need to make sure that when you have a higher workload, which strategy you are going to follow. Planning is very important phase. So you have to plan your migration on lot of factors. The one of the important factor is what is the business driver for the cloud adoption. When you are going to the cloud, what is that which is leading to this migration strategy? You have to consider the timeline as well. Assuming I have a database which is 10 terabyte in size, and without proper POC, without testing to the cloud, when we do the final migration, it is going to lead a lot of problem because we have not done the planning and assessment properly. You need to check out the business and the financial constraint as well. Some of the applications has to be 24 by 7 available. So is it that using your current strategy, you can do it within given timelines? The financial constraint, assuming if your website is down for X number of hours, your penalty will be huge. Say for example, you have to keep it down for the migration. Though there are migration strategies which are available wherein you don't have to shut down your database or the application for most of the time, but when it is the final switchover, that time you have to take care of it. In case you wanted to sustain your current workload to the cloud, if you are choosing for rehosting, let's say my EC2 instance, let's say on premises I have a PostgreSQL 10 which is running, and I wanted to go to cloud and I want it to be still in EC2, then you have to plan it accordingly, and it is one of the simplest way of the migration. You have to optimize the workload and the scale of the workload as well. So these are the few things. You can do the rehosting wherein let's say my Postgre is running on cloud, on premises on a virtual machine. You can just rehost it. It will be rehosted to the EC2 instance. You can use relocate feature of the AWS as well, wherein the VMware has this capability which can be used. You can optimize your workload. You can use the replatforming as well. So let's say you wanted to migrate to your database to Amazon RDS. Let's say from Oracle you wanted to migrate to Postgre, but you wanted to be on RDS. In that case, it is right replatforming. Or you wanted to repurchase. There are 7 hours. We are just going to discuss only 5 over here. Let's say you wanted to drop your entire this thing, the migration, and you wanted to change to some other application. In that case, also you can do it. There is something called as re-architecting as well, wherein you can say, okay, I don't want to be on the same engine, database engine. I wanted to change it. Not applicable for this scenario, but let's say in case you wanted to get rid of your enterprise databases, in that case you can go to some of the open source databases in the cloud and you can be over there. So you don't have to pay the license fees, but the underlying infrastructure that is built and you have to pay for that. Migration path we have already seen. Rehosting, that means you are already on in the on premises in PostgreSQL and you are going to the cloud and you will be there. When you say relocate, there is a feature which is available in VMware that can be used. You can use the repurchase, you can do the refactoring. This is going to be very important. Let's say refactoring or the re-architecting, these are the two words which are interchangeably used, wherein I'm going to change my database engine. So when we say changing the database engine, it is not so easy, but we are saying we are changing our database engine from Oracle to PostgreSQL, or let's say I wanted to change to the Redshift cluster, which is backed by Postgre itself. So you can do those things. You can take a decision whether your current workload is not enough. It can be combined with any other database which is running on the cloud, so you can do some kind of revisiting, or it may be possible that the databases you are not using, so you can retire it as well. We are not going to discuss about this because the databases, this is going to be very very important slide, which is the migration path. Migrate, this is the third phase. So we already discussed about PP, which is prepare, plan, and we are on the migrate. This is the third phase wherein we have to think a lot about the post migration planning. When the migration is done, what all steps I have to do. You have to identify a migration strategy in the migrate step, and you have to design your target database. Let's say my database is 10 terabyte, which is running on premises, and when I move to cloud, either I will be on EC2 as PostgreSQL, or I will be on RDS as PostgreSQL. So what are the different things which I have to do after the migration? Do I need to do the daily tasks which I have been doing earlier, like the maintenance activities? So it also depends upon the size of the database, because not the same size of database is applicable both in RDS or in your EC2 instance. You have to identify a migration strategy, whether it is going to be online, offline, or you have to continuously keep replicating that PostgreSQL which is on premises, or in case you are migrating from Oracle to PostgreSQL, then what are the different things which you need to take care? Let's say my database is still running. Is there any tool or technique which is available which can continuously replicate my source Oracle database to target PostgreSQL database? Then it comes about the designing of your target database. My source database was using, let's say, 24 CPU, some 100 and or let's say 96 GB of RAM. Is the compute resource on the target, it is going to be the same, it is going to increase, it is going to decrease? So those decisions you have to take care over here. And when it is migrated to the target, you have to make sure that you have a data validation plan in place, so that you can validate whether your data which is migrated is properly validated or not. These are the migration steps. You have to convert the schema in case you are doing the heterogeneous migration. For example, when you are going to the different engine, let's say Oracle to PostgreSQL, you need to convert the schema. Then there is something called as a schema conversion tool, SCT, that you have to use it. You have to migrate the data, because the schema will be changed but the data will be migrated. Then you have to update your application as well, that my database has gone to the cloud, and this is the identifier through which your application is going to update it. You have to test the migration whether everything is fine, and then when you cut over to the new database, you have to make sure that the last changes on your source database are migrated to the cloud as well. So when you are converting the schema, that is only required when you are doing the heterogeneous migration. It's not required when you are doing the homogeneous migration. And most of the time, the all the cloud service providers, they say you go with the native database tool. In case of PostgreSQL, you have PG dump and PG dump. All those, they are suggested that you should use it, and there are some kind of restrictions also in terms of the speed. So you have to make sure the database size is considered when you are, otherwise you have to take some of the other tools, which are, some of them are open source and some of them are paid as well. In case you are going for the heterogeneous migration, you have to make sure that you convert the schema. For example, you have to use the schema conversion tool, which comes as a bundle from AWS as well, which can convert the Oracle schema to PostgreSQL compatible schema. So this is something which can be done by the AWS SCT schema conversion tool. It converts the source to the target compatible schema, and it gives you the graphical GUI mode wherein you can connect to your source and target. Then it will tell you what source and target can be converted and wherein you have to make the changes, and you have to get rid of some of the things which are not possible at all. So this is something which will be kind of executive summary will be available when you execute the database migration assessment report, which is your schema SCT tool. So it will show you like what are the different things, like the number of the schema, number of the tables, number of the columns which are. So it is going to show you all the details. And when you have to migrate the data, when the schema migration is complete, let's say you have used the SCT, then it's the time to migrate your database. When it is the time to migrate your database, you have to choose proper tool. Let's say I'm using the DMS, which is migration services tool available from AWS, that will helps you in loading the data from your on-premises or from the cloud to RDS, in case your landing is on RDS as PostgreSQL. AWS DMS is a fantastic tool which can be used in AWS cloud, wherein if you're going for the heterogeneous migration, the first thing which you have to do is you have to you have to convert your source schema into the target compatible schema. Let's say Oracle to PostgreSQL, because the way the data types in Postgre and the Oracle may not be the same. So the data types will be changed, and there will be some data types which are available in Oracle, they are not available in PostgreSQL, something like that. And there will be those things that will be taken care by schema conversion tool. So it's all when you are doing it using the heterogeneous migration. So AWS DMS, we will be seeing it next session, like how the DMS is going to work, and it is going to be very useful when you are doing the heterogeneous migration. And one of the popularity of AWS has become because of the heterogeneous migration, and providing this kind of tool which can take a lot of pain when you have to migrate the databases heterogeneously. It is not like that DMS will do the one time migration. It can continuously replicate your on-premises data to the cloud. If you are going to the RDS or EC2 instance, it can continuously replicate it, and when you have to switch over, you can do the final it. So there are a lot of things which are available in DMS, and it's a huge topic. We'll discuss it sometimes later. There are some offline migrations options available. If your database size is very small, your application can support some time of downtime, then it is good to use some offline migration options as well. Let's say if you're going for heterogeneous migration from Oracle to Postgre, then you are supposed to use the open source tool, which is Aura to PG, which is of great feature, which can migrate most of your codes to PostgreSQL compatible code. And finally, you have to update the application, like these are the details of my target environment, and they can be updated accordingly. And finally, you have to test the migration when you migrate to the cloud, either to RDS or EC2. So we are not going to talk about how we are going to do it, but you make sure that enough testing is done, because the way the things may work in on cloud, on premises, and in cloud, there may be some issues as usual. Cutover, this is going to be the most important phase. The database cutover strategy is usually tightly coupled with the downtime required for the application, because when it is the cutover, you have to make sure the application is not accepting any connection, and the final changes on your database will be replicated to the cloud. And when the final sync is done, you have to stop your source database, and you have to connect your application to the cloud database. There are a lot of things which can happen during this cutover. You can do the offline migration, you can do some kind of flash cut migration, you can do active migration, you can do the incremental migrations. A lot of things are available, but in our case, when you are going to RDS, you have the fantastic tool which is DMS. If you are on EC2, you can continuously replicate your data from source to the target in cloud, or in case it is asking for you to continuously replicate database data. In that case, you have to use some kind of streaming replication so that the database data can be continuously replicated to EC2 instance on in PostgreSQL. So this we have already discussed, like what is going to happen during the offline migration, or in case it is going to be the online as well. So when we talk about the application offline for an extended period, then you can use the AWS DMS, wherein full load task setting can be done, so that the data from your source can be loaded to the target. And this is just the high level step. You have to complete the schema conversion, you have to start the downtime for the write traffic, you have start the migrate the database using the offline migration options, you have to verify your database, and then you have to point the application to the new database. Some of the things are repetitive, we have been talking them again and again just to make sure we understand how the things actually are going to work. And the final thing is the fourth phase, which is the operate and optimize. There, and you have to make sure, if you are not on RDS, if you are on EC2, you have to make sure that you maintain the proper monitoring, alerting, backup, and high availability as and when required for the cloud. You have a lot of inbuilt features available in cloud. You can use most of them, like CloudWatch, which can do the fantastic monitoring. And in case you have the RDS, then a lot of inbuilt features will be there for backup, upgrade, and other things. So you can use those things according to your requirement. And that's all about it. I hope there's just the strategies, like what shall we do. It is not going to talk you any technical stuff. It is just like, when we are doing the migration, when we are planning the migration, what all the different things which we should consider. We haven't talked about the technical parts, like what online tools available we have, techniques available we have, what are the offline techniques we have, what are the paid tools which are available in the market. We have not discussed about, are there AWS partners which can do it for us. It is just like, these are the different phases, and this is something which we have to do. So when we do it for the customer, we say these are the different phases, and in this phase we are going to this. I hope this is going to help, and in next session we are going to see in detail about DMS migration for PostgreSQL. So in that session we will be taking care of on-premises PostgreSQL to RDS PostgreSQL using the DMS. And finally, thank you for checking this.